Welcome to queenon7.com. Please share and subscribe my videos. We're going to look at today the carbonyls, especially about aldehyde and ketones. Three types of carbonyls we're going to look at: aldehydes, ketones, and carboxylic acid. Aldehyde and ketones will be divided into two parts, so we're going to look at the first part today, and the part two will come after. Carbonyls is actually when you have a C-double-O bond in the carbon chain, either at the end or in the middle. They are known as the carbonyls. When we look at the naming them, we're going to look at the aldehyde and ketones. You probably have done that in year 12, where you looked at actually the naming the carbonyls. If you look at the carbonyls, the simplest one, the example of one of the aldehyde is CH3CHO. There are two carbon atoms, so you will actually count the number of carbon atoms in there, and then you will look at the functional group. So whenever you see CHO group at the end of the carbon chain, that hydrocarbon will be known as aldehyde. It's a derivative of hydrocarbon. So the aldehyde, there are two carbon atoms, so it is actually ethane. But because the functional group is CHO, you remove E and you put Al. So that will be ethanol. In alcohol we use ethanol, if you do remember that. Same goes for another one of the other example. If I try to explain the side chain as well, for example, if I have this aldehyde, where you have a carbonyl group there and you have a hydroxyl group there, you will start the counting from the functional group will have the priority, so you will start counting from there 1, 2. So you name the side chain first, which is 2-hydroxy, and then you come 1, 2, 3, 3 carbon atoms. It is propanol. You don't have to write down the numbering for the aldehyde group, because it will always be at the start of the carbon chain. If I remove this and I give you an example of another carbonyl, which is CH3 C-double-bond-O bond CH3. This carbonyl is actually have the carbonyl A between the two alkyl groups. So whenever you see a carbonyl between the two carbon atoms or between the two alkyl groups, they are known as ketones. You will start the numbering from the closer, where you can get the closest position for the carbonyl. So from either way, it is going to be second anyway. So you can write it down as propane. Now 1, 2, 3 is actually the parent name for the hydrocarbon, which is propane. To name this sort of compound, you remove E and you put O-N-E. So propanone will be the name of the hydrocarbon. If you would like to see another example of a ketone, now propanone, in either way, you don't have to write down the position of the carbonyl group, but for the butanone, yes, you do have to write down the position of the carbonyl group. So but-2-1. So that's but means 1, 2, 3, 4 carbon atoms. Position for the carbonyl group is number 2. So but-2-1. I will actually explain all of these in another video, where we're gonna actually try to know how to actually name the hydrocarbons and the derivatives. Now we're gonna look at the solubility of the carbonyls. The smaller the carbonyl is, the more it will be soluble. So smaller the carbon chain is, the more it will be soluble. Because the small carbonyls, they will make hydrogen bonding. The longer you have the carbon chain, the more you will have London forces. These can have the hydrogen bonding, but when you have the big long carbon chain and you have carbonyl group there as well, it will actually have a permanent dipole-dipole interaction rather than having hydrogen bonding. So the small carbonyls are actually soluble. Now we're going to look at the oxidation. Is the first. For oxidation, you need potassium dichromate, K2Cr2O7. You also need dilute sulfuric acid. These are the two which are required to do the oxidation. Now, if you have an aldehyde, which, for example, if you have ethanol, and you're going to oxidize it with the K2 Cr2O7, and you will have dilute H2SO4. For the A level, you do remember, but sometimes they give you the reaction straight away, and they will actually ask you what are the conditions required to carry out the oxidations. You do need to remember the potassium dichromate and dilute sulfuric acid, and you will be converting aldehydes into carboxylic acid. So aldehyde will be converted into carboxylic acid. So this bond will be actually converted to COOH bond because of the oxidation. Now, if I try to oxidize another carbonyl, which is a ketone, and if I take an example of propanol, and I try to oxidize it, and condition will remain the same as above, it will not further oxidize because there is no extra hydrogen attached to the carbon which will undergo oxidation. So that's why the ketones will not further oxidize, and this is how you can distinguish between ketones and aldehydes. Now, there is one more lab identification test which we normally use, is actually the tolerance test. We also call it as a silver mirror test. Now, silver mirror test is if you have done it, then it's good. If you haven't done it, it actually produced the silver inside the test tube will actually give an indication whether your compound is an aldehyde or a ketone. Normally, when you convert the primary alcohols, they actually further oxidize to. If you look at my previous video, which I have uploaded, primary alcohols convert into aldehydes upon oxidation. And the secondary alcohol, they are converted into ketones, and the tertiary alcohol, they will not undergo oxidation. Primary alcohol can be further oxidized to carboxylic acid under reflux, and you have sulfuric acid there as well, and K2Cr2O7. Now, when you have the two carbonyls with you, and you want to distinguish whether your product is actually aldehyde or ketone, you will be looking at reacting that aldehyde. For example, if you have an aldehyde in your in the solution, you will be reacting it with the silver ion. Now, silver ion actually be produced by intolerance reagent. You will have NH3 aqueous solution, and you will have silver nitrate AgNO3. That will produce a complex which is actually a silver ammonia complex, which is actually the active ingredient to do the oxidation of the aldehyde. So that will produce a H positive ion there. Because it is aqueous, you need to write down the water as well. That's the overall equation anyway. This aldehyde always give you a carboxylic acid upon oxidation. You can see that aldehyde straight away converted into carboxylic acid. And then this silver will actually be reduced. It will actually gain the electron, and it will be reduced to silver metal. You will see as a solid. And then you have to balance the equation. So you put a proton on the side, because there are when you try to balance it, you have 8 protons and 4 water molecules, and that will balance the equation. And this is how you actually carry out the oxidation of the toluene. If you try to do the aldehyde ketone, it's not going to happen. There will be no silver mirror. You have to heat it gently after adding aqueous ammonia and silver nitrate in the solution, and that will produce the carboxylic acid and silver metal, and that will be deposited around the test tube. Now we will look at the reduction. Now, reduction is one of those reactions where I personally try to explain using a mechanism, and we will see how reduction will happen. It will have actually the nucleophilic attack on the carbonyls. Carbonyls do have some sort of electrophilic center. So if you do have an aldehyde or a ketone, because it's more electronegative, this oxygen, the carbon will be partial positive, and it will actually invite the nucleophile to easily attack on the carbon and provide the lone pair of electron or the pair of electron. Now, if this is the case, you need to use some sort of region which will give you a nucleophile. A nucleophile is a species which carry out, which a negative charge or it will have a lone pair of electrons. So any of them will be considered as a nucleophile. Now if I try to use NaBH4, which will provide hydride ion instead of H positive ion, that hydride ion will actually attack on the carbon of the carbonyl group, and it will produce CH3, C bond O, and this will be H. Now oxygen will carry negative charge this time because it's going to happen in aqueous solution. OH will come in place, and that will take the hydrogen out of water, and it will be converted into an alcohol. So aldehydes will be converted into alcohols upon reduction. Now we can actually use a ketone as well, and all we have to do is, if I remove this bit and I put CH3 there, so this is a propanone. Propanone upon reduction will actually have the same sort of reaction, and it will carry on. Only the difference you have is the CH3 there. And now this aldehyde has produced the primary alcohol, and a ketone will be producing secondary alcohols. Now this is obviously the reduction of the aldehydes and ketones. Now we'll look at the catalytic hydrogenation. Catalytic hydrogenation will actually give you the same product as a reduction. So if you have a CH3, CHO, and you do catalytic hydrogenation. For the aliphatic hydrogenation, you do need nickel as a catalyst, and you do have some sort of the acid in it, probably HCl. You can use the best one. So nickel, and you will have HCl, and that will do the job, and it will convert your product into an alcohol. So you will see the aldehydes will be converted into the primary alcohol. Ketones will do the same job as I can actually remove this to make it more obvious. You will have nickel and HCl, and you will get CH3, and this will be OH, H and CH3, and it will be tertiary alcohol. So both will actually produce the same product. Here I would like to mention that even if you forget this, you can actually write down platinum and palladium as a metal for the catalytic hydrogenation as well. Please do wait for my part 2 as well. Thank you very much.